ready?
Yeah.
Ready? Wayne's World, excellent party time, yeah.
Awesome.
Happy? How
Really good.
Mark, you were supposed to.
Really good, man. Thank you. I appreciate that. I was expecting since the first episode to have a highway to hell, like as an IoT, the IoT song.
It is. We've been living on the highway to hell.
Yeah. Speaking of highway to hell, we're going to be talking
next time Stairway to Heaven, maybe.
Maybe.
How appropriate.
We're still waiting for that.
Yeah. No, jeez. Okay. Yeah.
But Welcome to the Jungle would be a good one as well.
Yeah.
Yeah. That's a good one.
You know where you are.
I'll work on that. I haven't played that one in a long time. I haven't played that since Guns N' Roses was a big thing back in college, and that was a long time ago. That was basically when they came out, right?
Woo.
Great band, though. Wow.
I think we should find like the proper song for each episode,
Yes, and then we'll have to have Rick eventually play his bass. I know that guy is talented. I could tell.
Then that means that very soon you need to play When Summer's Gone. Very slow. It's from the Doors. What's wrong with Jimmy Morrison? You're looking at me funny.
It's fine, but it's just
I have to go to disc on that one.
too mellow. I don't think there's anything that's
No? All right.
mellow in the IoT world at the moment, unless you can think of something.
That's
Fair
totally
enough.
not in L2 cache. It's a cache mess, man.
Oh, man. But yeah, speaking of highway to hell, let's talk about blockchain. Right?
That says it all, doesn't it?
Yeah, and it's so unfortunate that we don't have Rick on and Stephanie. They couldn't make it this week, but we're going to kick off the blockchain discussion. I know this has probably been a topic that our IoT Coffee Talk audience has been waiting for us to talk about, right?
They've been holding their breath.
Oh, yeah. You have to.
Yeah.
It's just, waiting to get kicked, right? The tires are ready to get kicked. So let's start.
Yeah.
Who wants to go first? Who wants to give this thing a whale?
You want me to kick us off just by describing what it is? Just
really quick, and then I think we should also talk about, I think there's still a lot of confusion about how it's different from Bitcoin and the cryptocurrencies. And I wrote about this stuff and threw feces on top of it 3 years ago, and there's still people who are smoking the same joint. Quite honestly.
Yeah. Well, but really, you're right.
They are.
We would all probably not know about blockchain if it wasn't for Bitcoin, though.
Right.
It was a means to an end. Right? You needed so let's think about this in the financial world. Let's think about it in terms of blockchain. Of Bitcoin. What the point of all that was. With Bitcoin having this cryptocurrency, a digital currency that didn't require banks or intermediaries or exchanges, where everybody could trade money with each other, peer-to-peer, anonymously, maybe, all that kind of stuff, and know it's hack-proof and all that. And so to facilitate this kind of new internet type of currency that didn't need banks, where you basically have the Apple ad where she's throwing the hammer at the big old man who probably is the president of the bank, they needed to build something that was seemingly hack-proof, that was immutable, could not be changed. The blockchain is that thing. So typically, if we think about everybody on this call, I know you're all database people, database administrators. We have tables and rows and columns and data types, and that's kind of how the world works, actually. for storing data. Let's think about that in the financial world, though. So think about a bank, and let's think you have a bank account, and there's a table with a ledger, with it's you and it's how much money you've got, and maybe you want to transfer money to someone else or something like, or pay a bill. And so in a normal database with a bank, you would actually do an update to an existing row.
Yep.
To basically change how much money you have left. Let's say you took out $100, you do an update and change your existing balance to $100 less. And then over here, if it's in the same database or if you have to transmit somewhere else to another database, you would update that same a row for the balance for someone else or a business that you bought something from. And that's how it works. And obviously, banks are kind of like the exchange. Like when you think of stock exchanges, people don't buy and sell stocks with each other. They use an intermediary, an exchange to do that. So with blockchain, you don't do it that way. Blockchain is a database, but it's a different kind of database. It's always appending a new row, if you want to think of it that way. A new block in the chain is like a new row. So instead of updating an existing row and changing the balance, I put a whole new row on there, basically a new block that reflects that, and your new balance has changed or whatever. And I can't just do that and do an update query into a database. You have this quorum of lots of different computers, servers that all have copies of the same database everywhere. And they all have to agree that this is a good thing to do to make this transactional change. And so that quorum happens, and when they all decide, yeah, we're good to go, then that change is made, but it's not an update. It's always like an insert every time. So this database is always growing. Yeah. And it's happening in a distributed fashion using replication, which is near and dear to my heart. Partly, I used to be this replication guy with SQL Server a million years ago, and replicating data all over the place was a thing. So blockchain's doing that. And the reason it does that is to ensure that, it makes it almost impossible for hackers to go in and disrupt. Because what you don't like is hackers, if they find a way into your database through whatever layers of security, then they can manipulate, values in the database and disrupt financial services and all kinds of stuff. So this way, it's always appending. The word immutable means you can't change it. It's just always adding, and it's always a bunch of. And so a hacker would have to hack lots of, or hundreds, or who knows, thousands of servers or computers all at the same time to be able to break into what's going on there. And so that's kind of the thinking behind it. And again, it doesn't require intermediary. It's a peer-to-peer replicated database system. And so it could all just be individuals. And so kind of like the Wild West.
Yeah, in a lot of ways, it's almost like self-auditing because of the mechanism. And then there's the whole consensus algorithm and framework that's used to gain agreement and on what is quote unquote true, right?
Yeah.
In terms of data. And so that's, I think, some of the expectations that were set with blockchain that started this hype frenzy, that it's going to change the world and revolutionize the way that we think of money, the way that we think of assets, all kinds of stuff, right?
Yeah.
And traditionally, when we look at transactional systems, part of the process, or at least part of the maintenance process, especially if you start looking at forensics of, let's say, a challenge transaction, is you have auditing that goes on, right? That is theoretically delegated to this democratized trust framework. A lot of people call blockchain systems, or solutions, if you want to call it that, trustless systems, right? You don't need to have a single authority that tells you what is a valid piece of data or transaction. It's actually democratized. It's spread like across all of these nodes. They call them nodes, right? Which are those instances of the ledger. And like you said, the reason why they call them blockchains is they're usually a bundle of transactions put together in blocks that are committed to these long chains, these ever-growing chains of ledger data that are spread across the internet for God knows how many nodes. But for Bitcoin, I mean, you had all these miners that are basically using GPUs and these HPC computers and building, data. These guys that are building data centers in their basements, hogging up the electricity of their town or their city, trying to solve all these little mathematical problems that basically are used to commit these blocks of transactions to a chain, right? And so with the mining, it's not that blockchain is sort of this panacea for trust. It comes with a cost, right? And also the other thing that I've discovered over the years covering blockchain is that it is hackable at the endpoints and the applications that connect to it. Typically, the blockchain itself is not. It is immutable. It's very difficult to hack depending on how many nodes. And I think the minimum number of nodes is 6 in order for it to be sort of quote unquote bulletproof, right? But people get hacked all the time, and it's usually the applications. There's tons of people who've been investing in Bitcoin who've lost everything because the app wasn't secure. Right? So you can't think of just one layer of the overall solution as being secure or immutable. I mean, the fact of the matter is that you got ripped off, and the record of that you're being ripped off is immutable. Yes, you got ripped off, and guess what? We have no idea who ripped you off. But thank you. Have a nice day. Click.
This is why I keep my physical nano key for all the Bitcoin that I own.
Yeah.
In plural, all the Bitcoins that I own.
Yes, which are 0. Because I wanted to retire from this thing, but I wasn't in on the first wave of the Ponzi scheme, so I missed out. But I did invest in a really nice, came nice packaging little nano wallet here for
nice
Bitcoin.
Yeah,
just in case, but. Bitcoin's going to solve every problem. And I'm just saying that in hopes that, Rick picks this up and, takes it out on the next episode. But, all jokes aside, hearing Rob and hearing you, Leonard, I'm stuck as to, so in the context of IoT, where do we actually need Bitcoin? Like where?
Not Bitcoin, blockchain, right?
Sorry. Blockchain. See, the nano ledger got me stuck.
That's what I'm talking about right there.
When we're having the data acquisition conversation, we obviously have to make sure that the data that we're getting is good data, right? So the whole immutability thing, it's like, well, that sounds really good. But there are many ways to do that. And coming in at it from the industrial side, I mean, honestly, how many historians and distributed control systems have hacked data for the last, gazillion years? Like, it's really easy to prove. So I'm on the camp that on the hype side of blockchain, they are words, they're attributes that I like immutability that are really important in an IoT context, that there are 50 other ways of doing it without having to use blockchain, without having to consume ungodly amounts of power and other environmental impacts. So I'm on the camp of cool, what's the point? It doesn't do anything. And I would love to be publicly shamed, corrected, and educated should anyone want to take me up. I would listen. That's where I stand.
Can I get my word? No, well, I think that it's a very new technology. So, I mean, I agree with David. Today, there are not a lot of use cases where using a traditional database improves the situation or improves the situation of using a blockchain. There are some exceptions, but I mean, it's 3, 5, or 7 years with this technology. It's still not enough mature. We have to admit that. But it's interesting. But having said that, all of this peer-to-peer and non-centralized technology, that gives first thing that it gives, that it's really important, and I missed last episode of security, but first thing that it gives, so with this blockchain, it's a cryptography. So it's really important that it brings a new layer of security, or at least of encryption of the data. That's important because, with IoT, all the examples that I wanted to talk last week, or last episode, that I hope that there will be part 2 in some weeks. It's how companies are not using cryptography at all on IoT, or they prefer to save that dollars for an enclosure or whatever. I mean, I think the use of cryptography, thanks of the blockchain, it's important. Having said that, it increased the prices of the hardware. Second, it's all the business models that I have seen that involves a blockchain with IoT creates this new business model where sending data, for example, have a cost. No, till today, sending data it's more or less free if you use. That's not true, because if you use a third-party company that manages the connectivity, like with cellular connectivity or P1, etc., it has a kind of a cost. But even you will have this cost plus a cost to use a blockchain network that manages your data. So that increments the cost of your business model. So this actually disrupts the business model, because what's the added value that you get sending the data to a blockchain? The only use case that I have seen that makes sense to use a blockchain on IoT, it's only if the partners don't trust each other. So if there is this consortium of companies sharing an asset or something like that, where they don't trust each other, and there is a specific SLA, a service level agreement, that every year they have problems with that, etc. I think that potentially can be a good technology. Having said that, depending on the business model that this consortium of companies have, it will be hard to maintain a blockchain and database. But it's the only use case that I see that can work. And having said that, I tried in 2 or 3 projects, and these consortiums never buy it. First, because in one project they told me, no, we trust each other, so we don't care. So we use Excel sheets and we trust each other. But in order that they don't trust each other, some of them, they didn't want to be transparent, or it was too expensive, etc., for them. So it's interesting how that can increase. So that at the moment, first, technology is not enough mature, so maybe it spends too much energy, etc. Or it's in some cases applications are not enough secure. But you have to find this use case, this silver bullet, and maybe it is trust. Leonard already talked about that. No? If you have to trust, if you don't trust your partners, maybe that's the right approach.
Yeah, I think it goes back to what I was talking about before. Mm-hmm. It almost provides a proxy of trust. But I think in order to properly use blockchain in its current form of maturity, you really need to understand the limitations of the technology today, right? Number one, one of the biggest problems in a lot of implementations is folks start to realize how long it actually takes to execute a transaction or to make a transaction happen. So for real-time, even IT real-time applications, which are basically, the transaction went through overnight, it's tough. Now, when you start to bring it into IoT, which is what we love to talk about, it almost has very limited applications, other than for some of the things that folks are trying to do with it, which is use a blockchain solution as a way of instituting, let's say, a federated policy management or policy registry. And so doing lookups onto a blockchain is not as difficult. I mean, you can get much better response time from lookup transactions, but actually committing transactions into a block and doing it security, it comes with overhead, which is that compute, hence the energy. And then that makes it very limiting in terms of where you can deploy actual blockchain nodes. Right? Because these things, they have to have some sort of consensus mechanism, and that mechanism is going to require compute.
And for me, the most tricky part is how you trust the data that it's stored there.
So trust is an interesting topic. I don't think these things are inherently trustworthy. What they are is they can serve as a democratized source of authority. You can either subscribe to it as being trustworthy, or it can be completely shady, like Bitcoin. I mean, Bitcoin was originally used for drugs and probably funding North Korea's nuclear program.
It was a road, and it was made out of silk.
Yeah, all you know is at a certain scale, it can be immutable. And immutable doesn't necessarily mean it's trustworthy. What's trustworthy is what you're trying to do with this technology as an application, and blockchain itself is not an application. That's why I think it's ridiculous when people go around. I mean, think about all the people in the past, in the prior 2 years that were going around saying they're blockchain companies. There's still a lot of companies that go around and say they're blockchain companies, like there are companies going around saying I'm an IoT company.
Yeah.
But what do you really fucking do?
VCs. They had to say blockchain to the VCs during their pitch to get money.
Don't tell me that.
Thinking of Mark's comment also of the added cost. So, from a business perspective, let's if there was a use case where there would be value for whatever reason to just make sure that the information that we're doing something with is the absolute source of truth, then cost wouldn't be an issue. That said, and back to immutability doesn't necessarily mean trust, right? Immutability means I cannot change it, but I don't know if the data is any good. And back to why do we need this? There's ways with metadata to just validate whether some data is suspicious or not. You pick a factory, and if I'm getting, I don't know, some readings from a variable frequency drive that I think it's odd. Well, if I've deployed IoT, I probably have other metadata of the area that would kind of tell me, is this suspect or not? Because there, on the industrial side, one of the horror stories is for an operator to view operational data that's not accurate. That's actually going to a place where bad things could happen, but it shows that everything is fine, right? It's a horrible scenario. Thinking in the context of immutability, again, it's great, but not necessarily through a distributed ledger. There are other ways to have this conversation and other techniques to validate that, the data we're using is good. So, okay, I guess we are just beating this thing up, and that was the whole point. So I don't feel too bad.
You know what? In existing databases today, just relational databases, what do you see either built into the database itself or apps that are using it through APIs? Every change is logged typically. There's a timestamp when a CRUD operations against a database. There's a timestamp, and depending on the application, there could be a column where you put the user, the person who actually made the change, goes in there, so that you have that audit trail in the database so that you know when the change was made and who made it. And that typically has been our checks and balances against hackers doing bad things to your database, or at least you know who did it and you know when it happened to trace back.
And then you have a ledger on the other side that's looking at the other side of the transaction that's doing exactly the same thing. So, yeah. And the velocity of the transaction, or it can support very high data velocities versus what we're seeing with blockchain. And that, like I said, that's the biggest issue right now. It also has trouble scaling.
Yeah,
it has tremendous trouble scaling, even though there are a lot of companies out there, companies out there trying to solve that problem, but no one's really been successful. I mean, I've probably had no less than 300 quote unquote blockchain companies contact me and show me their wares. And it's like, this is like a lot of nice mathematical, engineering mumbo jumbo, but where have you made this work? You
said the word velocity.
Yeah.
I remember tying this into IoT, early days of blockchain and IoT, people were trying to put peanut butter and chocolate together, and they stupidly said, yes, we're going to store all the stuff in the blockchain, all the telemetry coming in from our things. And therein lies the problem. That was their pitch. They were like, well, we're going to make sure that all the data from our things is secure and you can't change it and it's trustless, and they use all the buzzwords. I'm like, that thing about IoT is you could have tens of millions of messages per second coming in, and you pick the absolute worst way, an append-only, immutable, distributed, consensus, am I going to let this insert happen database to do it? And it's like, and so that kind of blew up. But you know what? It's amazing how dumb some money people are in funding some of these companies. They're like, yeah, that's awesome. Let's do it.
Yeah. Dude, I just want to tell you, at this point in this podcast, Rick is going, that was the point I was going to make. He's like pulling out his hair.
I've seen other IoT companies who didn't do that, who, you know how like your identity, you have identity in your IoT platform for the people who are using it, the things themselves, all that stuff. Some people were using blockchain to store that part of it, identity.
Some of the smart contract stuff with Ethereum and stuff kind of makes sense, but again, you just really need to understand the limitations of the technology and also the benefits. I think, to your point, they're very misunderstood, and getting some people who can go to the next level with this technology, help you think through not only, well, what are the merits of the technology, but then if you want to build something that's trustworthy, how do you actually architect that? Because these technologies are not intrinsically trustworthy. They don't garner trust. You have to build applications that are architected with a trust perspective or objective, and that's not easy, because like I said before, Bitcoin, you can hack the crap out of it at the edges. Then how trustworthy is it to you as a user when your wallet can get stolen for millions, and then there's no way to figure out who the hell took your money, who stole it?
It's just like
all the blockchain is doing is telling you, you got ripped off, dude. Good luck.
Yeah. It's like if you're a person who doesn't believe in banks or credit cards, and you say, I'm going to use cash all the time. And if you lose or somehow you have all that cash, let's just say thousands of dollars stolen, well, too bad. You have nobody to go to. American Express isn't going to help you dispute charges, or you're never going to see that again.
Yeah, the only thing that the bank knows is you took out $100,000. That's it. Said, okay.
So you're saying that my mattress is just not a secure way to stash money?
As long as you don't live in Portland, you should be okay.
But
that's the same with everything. I mean, if you have gold, you can have the same problem. If you have stock options from the stock market and the company just closed down, you have the same problem. I mean, it's no difference. So actually, last year, I think I read the first robbery. So someone got into a house of a guy with a ledger like the one that David has it with him, with a gun into his house. Give me the ledger, transfer me all of your Bitcoin.
Yeah.
And
that's starting to happen. That's normal.
Based on this, because this is public, I've literally just opened this. So thieves, there's nothing. I do not possess a Bitcoin, a fraction of nothing. There's nothing going on here.
Not here on this ledger. On the one on your mattress, it's another story.
Or my mattress.
We were driving to your house right now, but now we're not.
No, it'd be a waste of gas.
Yeah, and David lives in the Dominican Republic.
Yes.
He's not a U.S. citizen.
Over there. Yes. Behind the coconut trees.
Yes.
Now I'm thinking of Rob's comment regarding leveraging crypto and a distributed ledger at the identity level. Because if properly deployed in a scenario where you're not updating that ledger constantly, speed is not, it's not going to be a constraint, then it's very niche, but maybe I can deploy this at a router level to make sure that configurations, and again, maybe I'm doing this for a federal military contract. So I think if we flip it, and if speed doesn't matter, maybe you can come up with a good way to deploy it, but no one has scaled this. Like, I still ask, did you deploy this and has it scaled? And I'm yet to hear that, yes, here's where we did it. And it's not scaling, because of hype, maybe, right? Because blockchain is going to change everything. So there's the perception, but also because no one's buying this stuff.
You mean Bitcoin?
I keep saying blockchain. Jesus, just bleep it out and just put at every we're gonna have to automate this.
If you really want to scale it, you need to get your own nuclear reactor or a hydroelectric dam to give you some electricity. We all have stories about that. Of all these data centers being used to mine Bitcoins. I live in the state of Washington. Washington has a ridiculous number of rivers, and we have probably more dams than anybody in the U.S. And there were certain sleepy towns in eastern Washington right near hydro dams along the Columbia River that somehow magically we're using more power than major cities. They found out every last house, shack, abandoned restaurant, wherever, there were servers everywhere mining bitcoins to make those commits happen, right, on the chain. And so, and you're right, you get paid for mining, just like in the real world. I'm mining gold and I'm going to get paid. Yeah. And so, boy, it's hard to say that you're about sustainability.
No,
and be about blockchain as well, because it's like the least sustainable thing ever, not only in energy usage, but imagine it's a database that only grows forever. And so
everyone has a copy of it.
Yes, we're talking a new level of storage that's unprecedented, that's just going to keep growing and growing and growing.
Well, actually, there are some efforts to compress some old parts of the chain. So, I mean, the example that you're explaining, probably 50 years ago, the first databases probably as well, or the first computers probably as well, spend a lot of energy.
Yeah.
So it's what I said at the beginning. The technology is not enough mature. I think the idea is brilliant. It will work on a specific use cases, not everywhere. But yeah, I mean, it needs to be polished in a lot of angles of the diamond.
Yeah, I mean, I think at the end of the day, what we're just trying to tell the audience, though, is that, it can be useful, but you have to be extremely thoughtful about how you use it. You just can't go off of what these guys are pitching and trying to sell to you at like a blockchain conference. Do you know what I'm saying? I mean, But
Leonard, I would generalize and I would say, if you use any database, every database is designed for a specific scenario or a specific use case. You cannot use like a NoSQL like Cassandra to store like login and password. Probably you can do it. It's not created for that. Right. So, you cannot use something else for geo data. So, I mean, it's not just, so if we put blockchain into the database category, every database has been designed for a specific use case. I would change even blockchain for database, with your discourse. I would, if you change blockchain by database, it makes sense. So if you use one database, it's because you understand what you're going to do and actually what queries are you going to do against the database.
Will you allow me to disagree with what you say?
Of course.
The only thing I would say is the only reason why we're talking about this database is because it's so highly hyped, is the only thing I'll say. Cassandra and all these other things, I haven't done database stuff in a long time, so shoot me. It's not.
Don't worry. I'm going to let you finish.
Okay. Yeah, I'm done. I'm
hey, finished. You know what? The hype part of it, one thing we didn't talk about was an initial coin offering.
Oh, God.
I actually know guys from a startup that completely rescued their startup by doing an ICO, and they made tens of millions of dollars off that. Yeah. I have no idea what happened to all the people who bought into that deal now, but I don't think they're ever seeing their money again.
Well, it's an immutable transaction, right?
Yeah. I mean, the IoT World Congress thing, in Barcelona that would happen in October.
Oh,
and then they had to throw in a blockchain part to it. And there's a whole section there in Fira Grandia where there's the blockchain section.
Yep.
And the most highly attended sessions were people talking about doing an initial coin offering.
Yep.
And because people are like, I'm going to make some money, right? That's what it's all about.
Yep. And then the last 2 years, you look at that section, it's basically empty booths and empty stalls. I'll post a picture of it on this episode, but it's sobering. But yeah, you do still have these folks going around calling themselves blockchain companies. It's just, they're just embers after the fire.
But we have to recognize there are some really, really smart people who even today are saying they think blockchain is just as significant as the internet itself and its lasting power it's going to have over society or financial or whatever. They may be wrong, but there are lots of really plugged in smart people who still believe that. I have to at least open my mind to the possibility that they're right, and then I'm missing something.
Well, I have to say that
David says, but ask good questions along the way. That's it. because absolutely, the technology is changing, and
I'm going to go against everyone here, or I don't know David's position, but I have to say that I'm really excited with helium. So it's let's start a discussion if you want. But yeah, it's a LoRa gateway. It's a LoRa network that it's based on blockchain to prove coverage, to prove the messages, etc. And it's using like a cryptocurrency to reward the people that provides coverage of the LoRa network. I think it's a kind of an iteration of the Things network, LoRa network, trying to reward the people or the companies who provide coverage and who prove that the messages are correct and are well sent and well received, etc. So, and it's growing. It's really interesting how it's growing, and there are a lot of crypto freaks there. Just because it's a really interesting project. I don't know how it will go. That we will need to wait some years, but it's at least a pretty exciting project.
I can't speak to helium, but because of the hype, sometimes today there are things being put out there of this entity has solved this issue by using distributed ledger technology. Right. And it sounds really good. And I'm not calling it blockchain anymore. I had some more coffee and I got it. But we don't have a view into, like, if we were to look under the hood behind the scenes, at the end of the day, was it actually DLT that was used? Was it actually cryptography, or was it just something else? And that's part of the the asking better questions and the hype cycle, because I mentioned on our chat, and I'm not intimately familiar with, again, what's under the hood, but, the government of Estonia for a few years now, they've been leveraging some of this DLT technology for their digital government. And again, so if they are actually using distributed ledger technology for this, I think it's great, but I don't know. They say they do. I don't know. I mean, I think it's credible, but anyway, that's where my head went, Rob, because to your point, there are wicked smart people out there that are trying to solve problems in a new way with this new technology. So there, officially says something positive.
Yeah, that's positive. But you know what? I mean, on those lines, you're right. A lot of smart folks, you hear people all the time saying, why can't we vote for president online?
Yeah.
And obviously we know we'll be hacked to death. But the people who say blockchain might be the only way we can make that happen in a unhackable way. You're right. I think in government, in that whole, how do we do that zero trust world and be able to vote for people in Congress and Senate and president or whatever, and know that your vote hasn't been changed. Blockchain might be the answer to that.
Or that Rob the candidate got 23 votes out of a total population of 8. That is so strange. I mean, you're a popular guy, but what just happened?
How many of those people?
But that can happen with any type of database. I mean, you can do with SQLs.
Just like one real quick thing about helium, I guess the thing that I question is how big the economic pie is for that. And I think, even for some of the ventures that I've seen where the pie looks apparently large, I think that from a business model perspective, a solution perspective, that's one of the things that you need to really look at. Because in some scenarios, the pie isn't big enough to sustain the solution itself, right? And it makes no sense. And that's the thing that you have to think about. And then also, how important is immutability and all this stuff, and how difficult is it to actually architect trust and security into all of it, because you have a secure database and everything else is like crap, then guess what? You're going to get hacked and all kinds of bad things happen, and you're going to have to buy a armor-proof or armored mattress, right, to store all your money. But with that, hey guys, I'm done here with my coffee. I got to get a refill. Save that for Rick. I see you, Mark, wanting to disagree with what I say.
Just a comment.
No, next week. Save it for Rick.
No.
Okay, really quick. It has to be.
Yeah. No. But you are talking always about hacking the database or the blockchain. But you have to think that it's not hacking. It's someone, the owner of the database, can change it, and that's what's not possible with.
That's what I'm not talking about that. I'm assuming that the blockchain distributed ledger database, whatever you want to call it, is immutable. It's absolutely secure. The application is not secure. It can be totally junk around a very secure, immutable database.
But that's any application, actually, not just blockchain application.
Exactly. And that also means blockchain, unless you architect trust, these fanciful things that we're expecting out of blockchain, unless you architect it, implement it correctly, it's just any other system, is my point.
Actually, no. The point is that if you use a normal database, you can. Yes, you love that. Actually, if you use a normal database, you can change it. I mean, I'm the owner of the database. So even if there is an audit trail, whatever that Rob mentioned before, I can change it easily if I own this database.
Yeah.
If we all own a part of the database with blockchain, that's really hard. So we already talked about that. So that's the difference. The application is hackable in any application. We don't care what database it's used. But the problem is that the owner of the database can change it. Imagine your bank would be able to change the money that you have or introduce you a loan for you. So that's what with blockchain will not be possible. That's the main difference, I think
that's a great point. That's actually a really good point. That's the beauty of having, a diverse group of people talking about these topics. That's actually a really good point, dude.
In diversity we trust.
Yep.
In diversity we trust.
Okay. On that note,
let's just keep talking for another hour.
I don't trust that. Anyway, to our audience, thanks for listening in. Remember to press the subscribe button when you go to the YouTube channel at www.iotcoffeetalk.com, and we'll have to have Rick come on and have his say. I'm sure he's chomping at the bit, and same with Stephanie. And so we'll see you next week.
Cheers.
Bye-bye.
Adios.